we are going to continue from where we stop on our probability. Today we are going to enter into what? Conditional probability. Conditional probability and bias theorem. Today we are going to look at what? Conditional probability and what? Bias theorem. What did I say? Today we are going to look at what? Conditional probability and what? Bias theorem. Now let's start with what? Conditional probability. Conditional probability. We are starting with what? Conditional probability. Now the conditional probability, of event A occurring, the conditional probability of event A occurring given that an event B has already occurred is defined as probability of what? Probability of event A occurring given that B has already occurred, which is equal to probability of A intersection B all over what? Probability of what? B. If and only if probability of B not equal to what? 0. Now, probability, when we talk about conditional probability, we are talking about when the probability of an event and one event happening when other event has already what? Occurred. Now, the conditional probability of event A occurring given that an event B has already occurred is defined as probability of A given that B is equal to what? Probability of A intersection B all over what? The probability of B, if and only if the probability of B not equal to what? 0. What did I say? Probability of A given B is equal to probability of A intersection B all over probability of B, if and only if probability of B is not equal to what? 0. Okay? What did I say? If and only if this is what? Not equal to what? Hey, I'm sorry. If and only if B, probability of B is what? Greater than what? 0. Okay? So this thing is hold like this if and only if the probability of what? B is greater than what? 0. So, and if the two events A and B are what? Independent. If the two events A and B are independent, if the two events are independent, now the probability of what? A given B is equal to probability of A times probability of B all over what? Probability of what? B, which is equal to what? Probability of A. Okay? This thing holds like this if that two events we are talking about are what? Independent. And I stated earlier before that in our previous class that two events A and B are said to be independent if the occurrence of one does not affect the occurrence of the other event. So let's quickly look at one example. Now, example 1. In a certain city, 45% of the inhabitants have black skin. 25% has brown eye, and 15% has both black skin and brown eyes. Now, if a person is selected randomly, from the city, find number 1, if it has black skin, comma, what is the probability that it also has brown eye? The question said, in a certain city, 45% of the inhabitants have black skin, 25% have brown eyes, and 50% has both black skin and brown eyes. And a person is selected randomly from the city. They say we should find the probability, if it has black skin, what is the probability that it also has brown eyes? This is called a conditional probability. They say we should find the probability of what? The probability that it has black skin. If it has black skin, what's the probability that it also has brown eyes? So let's start. Let A solution let A be event of having black skin, B event of having brown eyes. Okay, let A be the probability of having black skin, and B the probability of having brown eyes. So the probability of what? The probability of A is equal to what? 45%, which is equal to 45 over 100, which is equal to 0.45. Now the probability of B is equals to 25%, which is equal to 25 over 100, which is equal to 0.25. Now the probability of having both A and B is equal to probability of A intersection B, which is equal to 15%, which is equal to 15 over 100, which is equal to 0.15. Now the probability, our conditional probability now will be the probability of what? They said, what is the probability? The question says, what is the probability if it has black skin? So if it has black skin, what is the probability that it also has one eye? So here we have the probability of brown eyes, given that it already have what? Black skin, which is equal to probability of having both black skin and brown eyes all over the probability of what? Having black skin, which is equal to 0.15 all over what? 0.45, which will give us 0. What? This will give us 0.0.0.0. That is our final answer. So this is how conditional probability works. The conditional probability of having, the question says it already has black skin, and now asks you what to find the probability that it also has brown eyes. So putting it in this formula, this is defined as what? The probability of their intersection all over what? The probability of that particular event that has already occurred. So which will give us, this is the probability of the intersection all over this probability of having black skin, which gives us this final answer.